Hello everyone, welcome to this session. In this session, we are going to talk about the support vector machine for beginners and the kernel trick. So regarding this particular topic, we know one thing is that it's one of the most important machine learning algorithms that we use. And in this particular session, we will talk about what is classification, how do we do the classification with the help of the support vector machine, what is the maximum margin boundary, what are the support vectors, and what is feature mapping, and the kernel trick, and how we use support vector machine in the real world applications as well. So I'm your instructor, Sajjad Manzoor, and let's get started. So the classification, when we talk about the classification, it is simply like how we want to do the automatic sorting. So for example, if you want to do some sorting, like machine do the same thing as well. Like, for example, if we are having some emails and if I have to check it out, is that if this particular mail is a spam or not. So this can be done with the help of support vector machine or in general machine learning. And for example, again, another example of for example, if I have to do the classification of the photos of that dog and cat or any other animal. So that can also be achieved with the help of this particular machine learning algorithm. And and again, an important application is the in your banking system, in your finances, where if you have to see a particular transaction is a fraud one or a legit one. So for that as well, we use machine learning as well. And in particular, we can use support vector machine. So this particular supervised machine learning model is very helpful when we have to use it in the classification. So if I say what is a classification, is simply like we have to draw a certain boundary or a decision boundary. And when I say decision boundary here, we have an example where we are having two different classes. You can see class A, which is in these are the red dots, class A, and we have the class B, which are the black dots. So what we want to do here is that we want to make them separated so that we can achieve the classification. So this black line is your decision boundary. Another name of this decision boundary is your hyperplane. And then these dotted lines are your margins. So which touch your support vectors. So the thing that is how we can achieve the maximum margin to do the classification. Here we are having three different examples. So in the first example, if you can see your hyperplane line or a decision boundary line is very close to the class A. So is it a good boundary? Is it doing your classification properly? I must say no. Similarly, in the second case as well, you can see this particular hyperplane line is close to your class B. So is it doing the justice and is giving you the better results? You can say, is it a better decision boundary or a hyperplane? The answer is no, because it is not giving me the maximum margin. It is aligned towards one class only, not the second one. And it's very far away from the second one. Similarly, the third one, if you see the best boundary condition, is that which is separating these two classes equally and giving us the maximum margin as well between these two different classes. So the thing is that many lines can separate the class, many lines. This line is also separating the class, this line is also separating the class, and the third one, which is our best boundary, where we can apply our support vector machine, is also separating the classes. But the SVM will pick that one line which sits as far as possible from both the groups. You have to separate both the groups so that you can say it has classified your classes properly. So that is what we call as the maximum margin boundary. And when we are having the wider margin, you can say your model has given you a better and confident classification. Now, two important concepts that we have in support vector machine. First of all is the margin, and the second one is a support vector. So margin, as we talked about earlier as well, is the gap between the decision boundary and the closest point from each class. What are the closest point? So these are the closest point and this particular line. So the margin, the gap that we want to have between these 2 points, between the point which is the closest point from each class and the decision boundary should be the maximum. Sorry. So we can think of it as a buffer zone. The wider it is, the more forgiving and accurate your classifier. So we want to separate these two different classes as far as possible. The more the margin, the more good is your model in predicting or in classifying. And the second thing, which is also important, is the support vectors. So the points that the first point as this particular line gets along along the classes, and the closest point is known as your support vector. So here you can see these are two support vectors because in this margin line, these 2 points are falling on it. And similarly, for the class A as well, this point is your support vector. Why? Because this point is falling on the margin line and it is giving me the maximum margin. So I'm repeating it again and again that we want to increase the margin width or the margin between these two classes. So that is what we do here in the support vector machine. Okay, so now this is plain simple. So this in this particular session till now, what we have done is that we have understood how the support vector works and what is support vector machine and what are the support vectors and what is the margin. So in this particular, and we have separated it, we have classified it. But now, is the real world going to look like same? Are we going to get these two classes? Okay, and this is class A and this is class B, and now you can pass your decision boundary or your hyperplane through these classes and classify it properly. The world is not accurate, and the world is not as per our demands or in discipline format or in discipline. The real world applications are distorted. The data is distorted. So here we can see one example. What will happen if we are unable to separate our data? So for example, if you are having 1D, not linearly separable data, so here you can see one example. If I want to pass a line through this particular data set, I'm unable to do it. So why? Because I'm having a class B here, some data points here, and then I'm having class A, and then again, class B is getting started. So if I start to map it, if I want to do the classifier, or if I want to pass my decision boundary through it, there's high chances that the accuracy is not good. I'm not going to achieve a good accuracy. So for that, to achieve a good accuracy from this data set, what I'm going to do is that I'm going to go for the feature mapping. From 1D, I'm going to convert this particular problem into a 2D one. So I'm doing the feature mapping here. So with the help of that, what I'm going to achieve is that a particular line, the essence of mathematics comes here, that a particular line is now getting converted into a parabola. So here you can see it was, for example, y is equal to x, a simple equation, and now simple line equation, and now it's getting converted into a different equation, which is y is equal to x squared. So that's the equation of a parabola, and that comes into a 2D. So here you can see now the curve looks like this in the second one. And if I want to pass my line through it now, there is something that I can do, which was not achievable in the first place when I was having simple my linear data. So now I can pass my line through it and separate the data. So both these classes, class A at the bottom and class A at the upper one, are getting separated. So this is how kernel trick works, or we can say our accuracy gets enhanced when we do the feature mapping in the support vector machine. Similarly, you can apply this particular example here as well. For example, if you're having a different data set, you're having a 2D data set, and these are the circles, class A surrounded by class B. So if I want to pass my line through it, so that means simply I cannot just tell my machine learning model to work on this data without doing something to get the better of it. So what I'm going to do is that, again, I'm going to use a feature mapping. So for this, what I'm going to use is that one function which is known as a radial basis function, which is also a kernel trick. When I'm going for the transformation of it, kernel trick is nothing but it is a mathematical formulation or the transformation. So with the help of this transformation, what I'm going to do is that I'm going to separate these particular points of the classes, and now I can see I'm having two different classes, and I can pass my line through it and get a different result. And with improved accuracy, and I can say I can use this particular model. So this is how kernel tricks helps us. So when we say the kernel trick, we are having a lots of different types of kernel tricks. We can use a linear kernel, which we use for our simple data sets. Okay, so the strength of this particular data set is that it is a fastest. We don't have to worry about parameters here, much parameters, and it is used when we are having a linearly separable data. Okay, and again, the second one is a polynomial kernel. So we are going to use it when we have to interact with our features. We have to see how our curves is there, how our data set is aligned. So for that, we are going to use the polynomial kernel. And the strength is that it will capture feature combinations. And it's best used for when we have to go for the feature interactions and the images. Then you have the Gaussian kernel or the RBF kernel, which we have the equation exponential of simple equation of y is equal to exponential of minus x squared. So when we go for this particular Gaussian transformation is that it just separates our data, as in this case. So here we have applied this particular radial basis function or the Gaussian function, and this transformation results. Again, you can see it was a 2D image, and now when I apply the kernel trick, it has transformed it into from 2D to another higher dimension, which is a 3D one. So it is very flexible. It is for use when we have to go for the complex classification problems. We use the radial basis function. So these are the results that we can have comparison side by side of all these kernels. For example, if I'm having a linear kernel, if I'm having a radial basis function, or a polynomial kernel. For all these cases, I can see I can apply different types of kernels. So in the linear kernel, you can see my hyperplane is passing through it. So in that case, my accuracy reduced very less. So my accuracy is like 60% only, and it will be vary in this particular range only. And then if I'm applying RBF kernel, my circle is getting transformed, and after getting transformed, I can easily pass my 2D hyperplane through it with a enhanced accuracy. Even I can achieve 100% accuracy as well. Similarly, with the polynomial kernel as well, I can just see how my graph is varying, how my data points are varying. I can apply my kernel trick, and it will also give me a very good accuracy. So this is how the kernel trick gets used in our support vector machine. So now this support vector machine, where do it find the application? As I said earlier as well, it can find your application in the emails, in your medical, in your finance, where you can go for the fraud detection. In the medical, you can go for the cancer detection, and NLP, natural language processing, where you can go for the sentiment analysis with the help of the support vector machine. And if you have to go for the biology students or the biological field, if you have to go for the gene classification, you can go for there as well. You can take the help of support vector machine there. So if you are having medical imaging, email and spam, bioinformatics, everywhere it is getting used. Where we have, for example, you have to go from lower dimensions to the higher dimensions, we use support vector machines and the kernel trick. So the key takeaways that we have in this particular session was we understood what is the maximum margin boundary, how we want to, for my better classification, for a better accuracy, I want my maximum, the boundary margin should be the maximum. Okay, and second, how feature mapping is very important to get the better results out of my data sets. And then I can apply my support vector machine and my hyperplane on it. And then we understood the various types of the kernel tricks that we are having, like the linear kernel, polynomial kernel, and radial basis function. And there are other kernels as well. And so this was from my end. I hope you have enjoyed this particular session. See you soon again. Thank you.